Welcome to Daily Papers.
Today we're talking about a problem you might not think about with AI. We see large language models, or LLMs, as these incredibly knowledgeable things, but their knowledge has a use-by date.
Right. An AI trained in 2023 doesn't know who won the 2024 Super Bowl or what happened in the stock market yesterday. Its knowledge is frozen in time. So the big question is, how do you teach an old AI new tricks?
Or more accurately, new facts. It's a huge challenge. The most common way is something called fine-tuning, where you basically show the model new information and retrain it a little bit.
But that comes with a pretty major risk, right? Something called catastrophic forgetting?
It sounds dramatic, and it is. The AI can get so focused on learning the new information that it overwrites and forgets some of the old essential stuff it already knew. You teach it about a new medical breakthrough, and it might forget basic biology.
It's like cramming for a test. You might remember the new chapter, but you've pushed out everything you learned last month. Plus, it's incredibly expensive to retrain these massive models.
Exactly. So a new paper from researchers at Nischay and Purdue University explores a much more elegant solution. It's called Scaling Laws for Hypernetwork-Based Knowledge Injection in Large Language Models.
Okay, Hypernetwork is a great sci-fi sounding name. What is it?
Think of it this way. You have your main LLM, let's call it the worker AI. It's a super smart generalist. Now, instead of trying to perform brain surgery on the worker AI to add new knowledge, we introduce a second specialized AI. This is the hypernetwork, and we can call it the toolmaker AI.
A toolmaker AI. I like that. So what does it do?
The toolmaker's only job is to create custom tools for the worker. You give the toolmaker a big pile of new facts, say your company's internal safety manuals or the latest financial regulations.
And the toolmaker reads all of that?
It reads it all, and then it produces a small custom-made adapter. You can think of this adapter as a specialized cheat sheet or a plugin. You then give this adapter to the worker AI.
So the worker AI's original brain is never touched?
Exactly. The worker AI stays frozen. It just uses this new temporary adapter to answer questions about the new facts. When the task is done, you can just unplug the adapter. No risk of catastrophic forgetting, and it's much more efficient.
That's a brilliant solution. But the researchers didn't just propose this idea. They wanted to see how well it scales. What does that mean in this context?
It means they wanted to find the rules for making it better. In AI, these are called scaling laws. A scaling law is a predictable relationship that says, for instance, if you double the size of your AI, you can expect its performance to improve by this specific amount.
So they're creating a recipe for success instead of just guessing what works.
Precisely. They tested 4 different ways of scaling up. First, they made the toolmaker AI wider, meaning more processing power in each layer. Second, they made it deeper, meaning they added more layers. Third, they increased the number of facts the toolmaker had to learn from at one time.
And the fourth one?
The fourth was scaling the worker AI itself. They tested the system with a range of worker AIs, from smaller models up to a massive 14 billion parameter model. They wanted to know what gives you the most bang for your buck.
To run an experiment that big, they must have needed an enormous amount of data.
They did, so they built their own. They created a new dataset called MegaWikiQA with tens of millions of questions and answers. It was designed to test not just if the AI could remember a single fact, but if it could reason across multiple facts to find an answer.
Okay, so let's get to the results. Did the toolmaker and worker AI system work as they hoped?
It worked, and the results were incredibly clear. They found that performance got better in a smooth, predictable way no matter what they scaled up. Whether they made the toolmaker wider or deeper or gave it more facts to learn from, the final answers got more accurate.
Was there one thing that made the biggest difference?
Yes, and this is a key takeaway. The biggest performance jump came from scaling up the target model, the worker AI. The lesson is if you have a limited budget, you're better off using a smarter, bigger worker AI with a decent custom tool rather than a basic worker AI with a super fancy, oversized tool.
That makes a lot of sense. But how did this whole hyper-network approach stack up against the old method, fine-tuning?
This is arguably the most important finding in the whole paper. When they tested the AIs on questions that were very similar to what they'd seen in training, both methods were pretty close.
But that's not the real world. In the real world, people ask questions in all sorts of weird ways.
And that's what they tested next. They evaluated the models on what's called out-of-distribution data. These were questions from completely new subject areas the AI hadn't been trained on, like philosophy and linguistics, and questions that were rephrased in different ways. This is the ultimate test of whether an AI has truly learned something or just memorized patterns.
And how did the toolmaker AI do?
It was the clear winner. The hypernetwork method was significantly better at generalizing its new knowledge to unfamiliar situations. It didn't get tripped up by new topics or different phrasing nearly as much as the fine-tuned models.
So it's not just memorizing, it's learning in a more robust and flexible way.
Exactly. And what's even more exciting is that this advantage got even bigger as the models scaled up. This suggests that for the truly giant AI models of the future, this hypernetwork approach could be the most effective and reliable way to keep them up to date with new information.
So a safer, more efficient, and more flexible way to teach an AI new facts without giving it amnesia. It seems like a really foundational piece of work for making AI more useful in the real world.
Absolutely. It's a big step towards AI that can adapt and grow with our ever-changing world.
That's all the time we have today on Daily Papers.